Convert the surface 4y squared plus z squared minus x minus 16y minus 4z plus 20 equals 0 to standard form and classify the surface and graph it. So to start off, we're going to just simply write down the equation, make sure that we have it down correctly. So 4y squared plus, no, this is z squared minus x minus 16y minus 4z plus 20. So first thing we're going to do to start off is we're going to essentially complete the square for both our y and z variables and set the equation equal to x. So what we should have after doing some algebra is 4y squared minus 16y, just grouping our y variables together with our z variables together. So we should have 4y minus 16y plus z squared minus 4z, it's a 4, and we're going to have plus 20 equals x. Now, in order to set this to standard form, what we're going to do is we're going to complete the square of both the y and the z variable. We're also going to subtract 20 from both sides so that eventually everything can cancel out and we have a nice standard equation. So to complete the square, we're going to take the b coefficient, in this case 16y, and we're going to divide by 2 and square that number so that we get our c constant and our y polynomial. So we should come out with, we're also going to factor out a 4 just to make our lives easier. So we should end up with 4 times y squared minus 4y plus 4 and then we're going to do the same thing. We're going to complete the square for the z variable. So we should come out with z squared minus 4z plus 4 is equal to x. Now remember what I said earlier, we were going to cancel out the 20 here by completing the square, so we're going to subtract 20 to the other side, so it's going to be is equal to x minus 20, and because we're completing the square and essentially just adding numbers to one side, in order to balance the equation we have to add those same numbers to the right side of the equation, because we can't just create numbers out of thin air. So we'll multiply 4 times 4, and that's 16, and we'll add that to the other side, 16. Also, so 1 times 4, add 4, and this effectively cancels out the 20, so we're just left with x and our nice little polynomials here that if you look closely we can factor even further to create 4 times y, it's a very poorly drawn y minus 2 squared plus z. Essentially, since they're the same polynomial, we'll be getting the same numbers here, so it'll just be z minus 2 squared is equal to x. Now, if we look closely at our final equation here, this is essentially the standard form, but it also reminds me of this equation right here, which is z over constant c is equal to x squared over a squared plus y squared over b squared. B squared. Now this right here is the equation for an elliptic paraboloid, and in essence, this our standard equation for 4y squared plus z squared minus x minus 16y minus 4z plus 20 is the same as this equation for an elliptic paraboloid. The only difference being that x is the axis of the paraboloid instead of z. And if we draw it out, this is the graph that we should get from graphing this formula. Now, I know this graph isn't the very best representation, but seeing is believing, so you're just going to have to trust me in how this is drawn. You can, if you really want to check, go and look up a 3D graphing calculator to ensure that my drawing more or less lines up with how it should look like. And yeah, this is our standard form for the equation above. Now, on to part B, we have to find the parametric and symmetric equations for a line passing through the point 1, 1, and 2. And that is both perpendicular to both I plus j and j plus k. So when writing a parametric equation, the standard way to write them will be x with a constant xo plus t times a, and same goes said for y and z, except instead of x and xo, it's y and yo, z and zo. And for the symmetric equation, to find that, we simply set our parametric equations equal to t. So we'll just have, from our parametric equation, we subtract xo from x, and then divide a from both sides. So in this case, t and x, and this is, in essence, what the symmetric equations should look like from our parametric equations. So to start off, we're going to say where our vector coordinates a, b, and c are parallel to the line. We'll say that, okay, well, I plus j, the vector coordinates, can be written as equal to 1 for I is merely the x coordinate, and j as 1 for j is the y coordinate. And since there's no k, we write 0 for the k coordinate. So this is, we'll just say, is vector 1, and j plus k, we write our vector coordinates as 0 since there's no I, and 1 for j and 1 for k. And we'll say that this these vector coordinates will be called vector 2. And to find the parallel line of these two vectors, we merely take the cross product of them. So we take the cross product of vector 1 and vector 2. And to find the cross product, we use our matrix for I, j, and k. So we got I, j, and k. We have 1, 1, 0, and 0, 1, 1. Let's make this a little longer. And we find the individual calculations for the I, j, and k coordinates. So we'll have, let's see, I is 1 times 1 minus 1, so we'll have this is how we get the I-coordinate minus, okay, oh, no. So we multiply 1 by 1 and subtract by 0 times 0, which is just 1. So we should have, for our I-coordinate, we should have 1, because we have 1 times 0, and then we have 1 times 1, and subtract 0 from 1. Well, we just have 1 for our I and 1 for our j. So then we'll go to k, complete the same process. And after doing our algebra, we should come out with I minus j plus k, in which our vector coordinates can be written as 1, -1, and 1. And using these vector coordinates, we can then find our parametric and symmetric equations. So we'll say that our point, which is 1, 1, and 2, is equal to our constants here in our parametric equation. So it'll be xo, yo, and zo. So we also, our vector coordinates here are equal to A, B, and C, where our line is. So A, B, C. All right. So now we just plug the information that we have from our vector coordinates of I, j, and k, and our point 1, 1, and 2 into our parametric equations, and from our parametric equations we get our symmetric equations by solving for t. So our parametric equations should come out to x is equal to 1 plus 1t, y is equal to 1 minus 1t, and z is equal to 2 plus 1t. And like I said, to find our symmetric equations, we take our parametric equations and we set them equal to t. So for our symmetric equations, it will be t is equal to, let's see, to get t by itself, we subtract 1 from x and divide by 1, so it should be x minus 1 over 1, which is equal to y, okay, we're going to subtract 1, so y minus 1 over, and we divide by -1. And then for z, we'll have z minus 2 divided by 1. So z minus 2 over 1. And this should be, oh, sorry about that. This should be our symmetric equations for the line passing through point 1, 1, and 2.